Thank you very much, Ingrid. We at the Concrete Association, we really appreciate the opportunity to go ahead and provide this information to the industry and with partnering with LTAP on some of that. So um, I'll go ahead and start. And as Ingrid said, welcome to everyone. We're uh, we're very happy to be here and give some general knowledge on concrete inspection. If you do have any questions, feel free to drop those in, and we will get to those as expeditiously as we can. And we'll also have a Q&A at the end. We're going to go over a broad spectrum view of the concrete inspection. So just to give you a little bit of background about myself, Mark Meddaugh, Director of Construction and Education with the Michigan Concrete Association. I joined the MCA just a little over a year ago, bringing over 20 years of experience in the concrete industry. I started my career many years ago and through the Alpena Community College, getting my degree in concrete technology. From there, that moved me into a role as a quality safety manager with Oldcastle APG, which is hardscape products, pavers, SRWs. After that, I transitioned into working for an admixture sales company, BASF Master Builders. Was there for approximately 10 to 15 years. From there, I moved my career to Grand Rapids Gravel as I was a quality safety manager, or sorry, quality and aggregate manager for ready mix and concrete aggregates, along with standard aggregates. From there, my career transitioned to Consumers Concrete, uh, stepping back into the dry cast products and being quality control manager of their block and also landscape products. From there, I came and joined the MCA just over a year ago. Um, I'm a member of ACI chapters within Michigan. I've served on industry committees and associations, and I hold multiple ACI, MCA, and MCAT certifications that I've collected through my career. So, a little bit about the MCA. The MCA was established in 1952 as a forum of the state's ready mix concrete industry and as an educational resource for consumers as we're going through today. Michigan Concrete Paving Association was founded in 1968, the statewide professional organization of the concrete pavement industry, currently partnered with the Michigan Concrete Association together in 2009. It brought the Concrete Pavement Association and the Michigan Concrete Association together. Today, the association includes concrete paving contractors, ready mix suppliers, concrete contractors, cement companies, aggregate suppliers, equipment manufacturers, bulk material haulers, concrete product manufacturers, bonding, insurance companies, consulting firms, and other allies within the concrete industry. So the MCA has really grown over the years, and we involve the whole construction industry. So as you can see, we have a plethora of understandings. All right, so as we go through this presentation, a big thing we're going to go ahead and focus on are the objectives. We want to understand what concrete paving inspection is and how do we perform that. We're going to identify critical inspection points. We have many things that we can inspect within a concrete project or a construction project, but we're going to try to focus in on those specifics, the things that are going to make the difference. And then we're going to talk about some of the common deficiencies and how to prevent them with being an inspector. So, what's the importance of inspection? Inspection ensures that we're going to get a long-term durable product. We want to manage the quality, we want to manage the materials and placement, and which will then give us the long-term service. Uh, what does that also do if we have proper inspection of a project? It helps reduce the rework cost due to catching the issues that we may see in the construction process. And then also, being most of the concrete pavement is taxpayer involved, it helps reduce those costs and keep those costs and make sure that we are being, good stewards of the money for people that are paying it. And then we also want to make sure we promote safety. Safety is paramount. Um, it is one of the largest things that we need to focus on. on any construction project, whether it be concrete paving, whether it be underground, whether it be vertical construction, safety. We always need to focus on why are we being safe and what are we going home to? Safety hits very close to me. As I said, I did hold a role in safety, so make sure we're being safe on those projects, being aware. Sometimes inspection, you get caught up in the different things you're looking at on a project, and have to be cognizant of what traffic's doing or what cranes are doing. Really focus in on your safety and make sure that you're keeping that at the forefront of what you're doing. All right, we're going to dive into some concrete pavement types. So the two most common concrete pavement types is going to be, first one's going to be a jointed plain concrete pavement. Most all concrete pavements in Michigan that are designed are going to be a JPCP, which that means if you look at the picture on the right, that's going to be your standard jointed plain concrete pavement. You'll see the dowel baskets that transfer that load from slab to slab. Um, Years ago, we did have some continuously reinforced concrete pavements, but we don't see those anymore. The nice thing about a continuously reinforced concrete pavement is that it doesn't require those transverse joints, whereas a jointed plain concrete, we have to join it at those dowel baskets to ensure that we get the concrete to crack where we want it to. And that's usually at a lane width of 12 to 15 foot and then a length of 15 to 20 feet. With a continually reinforced concrete pavement, with all that rebar in there, we're going to naturally let that concrete crack, and usually from a 2 to 8 foot spacing. But with the higher amount of steel within the pavement, it holds those cracks close enough and tight enough that we don't have to go ahead and intentionally put that joint in there to relieve that stress. So the nice thing about a concrete continually reinforced pavement is that really the only joints we have to do is when the pavement ends or when we come up to a bridge. So each one has an application. So your JPCPs, you're going to see for common local roads and highways. So like I said, most of the Michigan roads here, with the experience we have, this is what we're going to see as, our JPCPs. And you can see an example of that on the right-hand side, and that shows, those joints being cut in there, and then you'll see your dowel bar baskets running through there to line up with those joints. Where on the left-hand side, you'll see, a continuously reinforced concrete pavement. This is really in the really heavy traffic areas. Sometimes you'll see these in limited spaces, or you'll see them sometimes in a manufacturing facility or like a truck docking situation, where that's really going to be taking a lot of those loads, and it helps go ahead and transfer that load easily from the pavement to the subbase. So a lot of it depends on, what the design life is of your pavements, what kind of loading it's going to have, and what the long-term maintenance plan is for that concrete pavement. So even though we do have, the concrete pavement is what we do see on top, we also have to go ahead and talk about what's underneath. And this is going to vary. I know Ingrid said we have some people from out of the state, but also mostly in the state. So we're going to be talking more to what Michigan, with the experience I have and the materials, is subgrade preparation. We need to make sure we've got a good foundation that our concrete pavements are built on. So we have to talk about compaction standards, and I'm assuming everyone is very familiar with density and getting density with the nuclear Troxler gauge, and compacting those materials. And we're looking for that 95%. Some of them may require up to the 98%, but a standard number that we come across in the industry is 95% of that theoretical maximum density. So if we take that material and we go, what is the maximum capacity we can get out of the soil? We're looking for that 95%. That 95% doesn't come without the correct moisture content. If we don't have the right moisture content for that specific given material, then we're not going to get the correct density. If it's too wet, we're not going to get the density. If it's too dry, we're not going to get that density. And that's why we got to get that optimum moisture. So we got to get that sweet spot, which most of the time, 5% is going to get you in the range of what we're looking for. If we're not going to be able to go with a density troxler gauge, we can look at proof rolling. Proof rolling is a great indication of if you have compaction of your soils. What we do is we take up, best case scenario, you'll take a dual axle or a triaxle dump truck and you're going to load that to its capacity. And then you are going to have your driver roll that across the pave or, the sub base and see where if you see any deformations, usually half an inch to an inch between the tires on the outside of the tires, seeing that material maybe pump underneath the load, that's going to give you a good indication. If you cannot take the density with a Troxler gauge, this method gives you a good indication if I have compaction or if I don't have compaction. So very nice to have.
We got a question in the chat about if everybody uses the modified proctor for their theoretical 100%, or do some agencies use the original proctor because they're going to get different results?
Correct. Yes. So if you do a standard proctor or a modified proctor, depending on what the specifications are, that's what we're going to follow. Some, like I said, are the 95, some are the 98. So it just depends on what your project specifications say. You're going to go to what each one of those is requirements.
Is one more popular than the other?
It depends on again the job in general. If you're going to send it back to a lab, or if you're going to actually do the modified proctor, standard proctor or modified proctor on site. So again, it goes up to the design engineer and then also the base materials that we're working with and, how much investigative work was done before to tell us what the soil. If we did soil borings and like that, they'll then take that back to a lab to get a better indication of what we're dealing with. Whereas if we're doing R&R, rip it out, replace it, and we're dealing with the materials there that may have been manufactured on site, then we'll, can run on-site proctors.
All right, thank you. That I think that catches us up.
Okay, excellent. And again, if you have any questions, feel free to reach out, through that chat, and we'll go ahead and talk about those. So a couple things we want to look at too is the bases. What kind of base we have? We're going to have a sub base, and that's going to be your existing soil, and that can go back to soil borings and kind of the investigative work before the concrete pavement design even happens, then from design to construction. So we're gonna have to figure out what we're dealing with on that sub base. Has to be, a good enough base to construct concrete on. If you have like a loamy soil or you have got a peat moss or something like that, that's gonna have to be over excavated and brought back in with a good granular material that meets the, design criteria for compaction. Then we're going to go ahead and go to our sub-base course. So this sub-base course has to support what is going to be put on top of it, for the loads being sustained. Most of the time that is granular. It needs to have a good draining capability. From there, we'll go to our base course. And this course is usually higher in density and has to be able to sustain the load that it's going to be put onto the concrete pavements. Thicknesses and gradations, that's all going to be done by a design engineer, for what they're looking for to support their concrete pavement. And then the tolerances, they're going to tell you how thick they want that, whether it's an 8-inch lift or 8-inch, 10-inch, 12-inch, depending on what those existing soils are underneath to go ahead and support that concrete pavement. In Michigan, and all around the state, we have to worry about drainage considerations. And a lot of times what we'll see is a longitudinal edge drain. So if we have an edge drain, we're going to go ahead and move. We got to get that water away from the pavement. Without getting that water away from the pavement, you're essentially going to create a pool. And water is our enemy. Water is one of the greatest things in the world, but it can also destroy the strongest products in the world. So we need to make sure we get that water away, and that's the best way to do it is an edge drain, if at all possible. With the edge drains, we have to also make sure that we have an outlet pipe and that we ensure that that outlet pipe is open at all times. As you can see from this picture, a 3% slope off of the shoulder. Most of the time, what we're going to see is a 1% slope at a minimum to shed the water off those pavements. We want to make sure we prevent the water getting into the base. So sometimes, that's why there's other methods. Sometimes you'll use some fabrics or over excavation to try to make sure that you can get that water moved out of the pavement. So we've done all our bases correct. We've built our pavements to design. Now we're going to go ahead and start constructing. This is some of the pre-constructing of the equipment, before we go ahead and pave the concrete. From what you can see right here, this is a concrete paver with a ride-on. It actually rides on top of that form. So that's where we need to check this alignment. We need to make sure we're working with our concrete pavement companies and ensure that the machine is aligned. So we're going to get a good, straight concrete road. Elevation checks. We also need to make sure that we're checking the depth, that we're getting consistent depth across the entire concrete placement. We want to also make sure we're checking the stability of the forms. We want to make sure that we've got good support on that form system. As you can see, there's a very large piece of equipment that's riding on top of these to, go ahead and give you the elevation. And, that these are good, stable. As you can see, this is a steel form system. And then anchors are spacing. And what they're referring to there is the dowel baskets. We need to make sure that those dowel baskets are placed properly and that they are put down into the subgrade to hold them in place. So if we are going with a jointed concrete pavement, that we are getting those joints in the correct spot so the dowel basket will transfer the load from A slab to B slab, B slab to C slab.
So we got a question in the Q&A. What happens if your undercut is lower than the edge drain?
I would have to refer to an actual engineer about that, on that specific. That would be a job site, um, and or design question. I'm not equipped to answer that, being site specific. You'd have to go back to your geotech, and your geotech would have to talk to your design engineer of your concrete pavement with an over excavation, situation like that.
All right.
All right. Go ahead and we'll talk about dowels and tie bars. Big thing with dowels and tie bars, as we talked with that jointed concrete pavement, is we want to ensure that we're putting those in the proper place, because these are going to transfer that load from a slab to a slab. Without these, or misalignment of these, you're not going to get proper transfer of these heavy loads in your roads from slab to slab. And that can, cut down on the service life of that concrete pavement. They do come in a coated or a sleeved as needed. A lot of times you'll see, if they are putting them into an existing pavement to put new pavement, you'll see them epoxied in, and the other side is a smooth dowel bar. A lot of times people use baskets. The advantage of the baskets are you can go ahead and place them exactly where you want them with stations. A lot of mainline concrete pavers also use mechanical inserters, and the actual concrete pavement machine will insert those dowels in the concrete at the specific distances and go ahead and create that reinforcing from slab to slab to slab. Equipment checks. This is a very big thing that needs to be done right at the beginning of the project. And then also, if there is any questions while you are producing the product, is to calibrate the paver and the vibrators. So the way we get consolidation with concrete pavements through a paver is to bring that material in, and then we use large vibrators within the machine to get the material to lay out, and then consolidate behind that to the correct depth. So we have to work with our manufacturers. As you can see, this one is a Gameco. They come out to site, or they help support concrete pavers out there to ensure that everything is calibrated and that these vibrators have the correct frequency to go ahead and give us the proper consolidation. We want to make sure as inspectors that we're looking the machine over and look for the cleanliness of the machine. Over the years and looking at this, if we have a concrete paver that's in good, clean condition, where you can see the hydraulic hoses, you can see, things are greased, the things look like they've been maintenance. The condition of the machinery usually gives you a good indication, what kind of product that the equipment can put out. Not that older equipment can't put out great product, but it can lead to hydraulic leaks, oil leaks, different things in the concrete pavement that you don't want to see in the finished product. So, good working condition, clean machines are always a nice thing. And then talking about fuel and backup systems, having those conversations with a concrete, paver. What is the backup if this machine goes down? What is your fuel frequency? Making sure that they've got the wherewithal to know and to deal with these situations when they do happen, because it's not a thing of if they happen, it's when they happen, and how that's going to affect you as an inspector, making sure you're ensuring a good quality product and that the public is getting a good durable highway. So the other one too, Mother Nature. Michigan is slightly unique, being surrounded by water. Um, as you all know, we can go from a 40-degree morning to a 90-degree afternoon, from a 90-degree afternoon down to a 50-degree night. So with concrete and inspection, we need to go ahead and document that. We need to document the morning temperature, the afternoon temperature, midday temperature in afternoon, or in night temperatures. So we have to take that in consideration and document that. We have to look for, do we need to provide windbreaks or sunshades? We got to look if we're going to have a hot morning, a cold afternoon, or a cold morning, a hot afternoon, and what the concrete contractor might need to do different to their concrete, with these situations. So we want to go ahead and document that information. And then as always, we want to make sure that we're not paving in the rain, because we will lose the surface of the concrete. And then freezing conditions. You never want to place concrete in a pavement application on a frozen subgrade. So in the line of inspection, we need to, inspect that subgrade, make sure it's not frozen, look at that forecast, and look at, we have to provide hot weather and or cold weather concreting practices. What are our ideal concrete temperatures? So most of your concrete temperatures that you want produced, 50 to 85. 50 is getting on that low point. Go project specific, and this is something you can, inspect. Is the picture of the thermometer is a standard concrete thermometer that has to read from 30 to 120. As you can see, this one reads from 25 to 125. They have to be calibrated, on an annual basis to make sure that they are proper. If we exceed, that 85, 90, 95 degrees, which, is going to be in your project specification, come risks. What are some of those risks? Through inspection, we're going to see rapid slump loss. And in rapid slump loss, we're going to see loss of workability. And loss of workability can, lead to other issues. And concreting practices aren't going to, promote the durability of that concrete. It's not going to be a long-term durable material. Low temps, similar risks come along. Low temps, we have to look at extended setting times. If we go ahead and start placing it 3 o'clock in the afternoon, is that concrete going to gain enough strength, gain enough time to go ahead and set and be a good durable material? With that, do we need to employ cold weather concreting practices? So as an inspector, you got to kind of look at that weather, document the things that are going on during the day, and know what these requirements are. So we're going to touch into concrete plastic tests. I believe Steve talked about this in his last one, but these are some of the standard plastic tests that can be done while on site. And as an inspector, you may be, watching over these tests, and or you may be performing these tests. But these are standard concrete tests that are out there to give us the plastic. And what I mean by plastic is the concrete coming out of, a central mixer, a dump truck, an agitator, a ready mix truck, you're going to sample the concrete. And when you sample that concrete, you need to make sure you're doing it with an ASTM 31. You're going to run your slump, which is going to give you, indication of the consistency of the concrete. A pressure meter, you'll run that to touch the air content of the concrete. Density unit weight, we're going to make sure we're using that to make sure we're getting the pounds per cubic foot within the design criteria, and the yield, so we know we're getting the concrete that we're asking for. We just spoke about temperature. We want to make sure we're in that range of the specifications. And then to give us a hardened concrete specimen, we're either going to do beams or cylinders.
We did have a question in the chat about that high temperature. Do you ever ice loads to bring the high temperatures down?
Yes, there's a couple common methods of reducing your concrete temperature. Number one would be watering your aggregates and letting your water cool the aggregates. If that isn't, enough, they can go to water chillers, which we can only bring the water down to 32 degrees, as we'll make ice cubes after. Then you can put ice in the concrete, but it's not recommended to put over, I want to say general rule of thumb is 70-80% of the total water that would be
Okay,
required in the concrete as ice. And if that doesn't work, there are some producers that can do liquid nitrogen
all
and
right,
put
that was
that
a
in the
comment.
concrete.
Then the next comment was that higher tech plants have the liquid nitrogen capabilities.
Correct. Yeah, and if you have a producer with liquid nitrogen, God bless you. That is a wonderful thing. It comes with other risks and rewards, but yeah, those are the most common methods to cool your concrete. If you can't get it below that maximum temperature.
All right, we're caught up on questions.
Okay, excellent. So like I said, back to concrete sampling. You have to take your sample right, so you get your slump right, your pressure, your air content, your density. You have to do all these correctly to get the correct design criteria that you're designing to. The other one that's not mentioned in here is the rollometer. If you're dealing with lightweight aggregates, you would need to use the rollometer or volumetric air content for those aggregates. So all these tests, this is just a good pictogram to show, from obtaining your sample to running a concrete temperature test to starting your air, your slump, and starting your beams and your cylinders. So it's just a good visual aid to tell us what's going on and what the time frame is that these tests need to be taken. So common mistakes that are done in the plastic testing is not dampening the bucket, not rotting, rotting too deep or too shallow, forgetting to tap the sides, wrong number of layers, not filling your pressure meter with water properly, not checking to make sure that all the pressure's out of the chamber, not having the correct initial pressure, not shutting the petcock so water squirts out, forgetting to hit the bowl, not applying an aggregate correction factor. So these are just some of the common mistakes, to the air tests that are out there that can, alter these numbers. And as you're inspecting, you're going to look and see how they, go with the contract documents. These are just some of the common things you can watch for when inspecting, that test. Testing frequency, that's going to be up to the specifications. A lot of times you'll see it, 50 yards, 100 yards, 150 yards. Some people do randomized testing within a lot, and then they'll have sublots to go ahead and figure out what that testing is. You can have QA testing, quality assurance, or quality control testing. This is all again in the contract documents, and they'll also talk about, do we need what type of testing do we need? Do we need air slump cylinders? Do we need air slump beams? And the curing methods that have to be followed for those. If we're going to have field cure cylinders, if we're going to have beams cured on site and broken on site. So all these things are variable. ASTM C94 does give us some guidance, but with most roadways being built, you're going to go to, if you're Michigan specific, MDOT, you could go to Federal Highway Administration. You might have a DOD, Department of Defense, or FAA. You have all these different entities that have different requirements. So always refer to your contract documents to know what that frequency is. So you know what you're inspecting, how you're inspecting, and what the requirements are. So we'll also talk about a little bit of time for placement, and this is variable depending on what kind of concrete you are placing. Pretty typical though is the 60 to 120 minutes, and this is really driven off of the temperature of the concrete and or the job requirements. In the job requirements, they'll also talk about retempering, and that can be found in ASTM C94, or again, you can look at your MDOT, your Federal Highway Administration, you know, what each one of those does. And when we're doing that, we want to also know that it's going to delay the placement if we are, retempering the concrete. And then do we have to retest it? Or do we reject it? So we also want to make sure we know what our suspension limits are or our rejection limits, and who do I contact if and when that happens. So with being an inspector, knowing what the flow of that information is, and what the suspension limits are. So do I go ahead and suspend the load, or do we go ahead and reject the load? So that goes into time of placement. Like I said, that 60 to 120 is very, pretty common, temperature dependent, mix dependent. ASTM C94 is now pushed that onto the supplier, to give that information, because they used to have, 90 minutes, 300 revolutions, up to 90 degrees, nothing below 50 degrees. But some of those things have changed with the newer, cements that are out there. So again, always reference your contract documents. Load consistency. This is going to be going to your slump test, but as you're, an inspector on the job, look for, visual inspection can give you a lot of information that's going out there, and then you can document it. You're going to look for uniformity and slump, color, and, the air contents that are being run. And then, like we touched on before, the defined lines of communication. With being an inspector, do I talk to, the foreman? Do I talk to the paver operator? Do I talk to QC? Who do I report my results to? But who do I also talk to get some action to get these things, these deficiencies rectified as the placement is going on. Discharge techniques, you're going to see multiple things out there. We want to avoid excessive free fall during discharge. So you want to make sure that concrete isn't free falling, whether it's a chute application, whether it's a tremie, whether it's a pump, you're doing conveyor, if you're dumping it out of a truck or an agitator. Um, Use the methods that limit this. So if we have to, get it from 30 feet in the air all the way to the bottom of the forms, we need to make sure we're using elephant trunk or, some other method to get the, putting the concrete pump down into the forms. Make sure that free fall is mitigated, because if we do have a excessive free fall, or methods that don't prevent the segregation, we're going to go ahead and cut down on the durability of that pavement and or structure. So circling back to the machine, the concrete paving machine, we're going to use, as you can see, it's got an auger in the middle to move that concrete from side to side, but also those vibrators that are on there that we want to make sure are calibrated and are within the working range, designated by the manufacturer. These are what give us the consolidation of those low slump concrete. The manufacturer does provide a range that these run in, for proper consolidation. The internal vibrators are spaced properly. We need to make sure that they're functioning. If we do have an over vibration, for the visual end, you're going to see like a line where the excess paste is behind the paver, and that'll create, that'll shrink more readily and create, lines in the pavement. If you have excessive vibration with a higher slump, you're going to see that concrete kind of sloughs off or falls behind the paver. The biggest thing that we're concerned about, in those two applications is the smoothness of the pavement, but also with over vibration, you're going to knock the air out of the concrete. And by, knocking the air out of the concrete, we're going to sacrifice that durability. Our biggest thing in the inspection world is to make sure that we're providing a good durable concrete pavement, for the public. Another thing we can do is talk about straight edge checks. If we are doing any kind of placements with a straight edge, we can go ahead and use this to check and see, how flat the pavement is. You're going to look for a quarter to an eighth of an inch over a 10-foot section to give you that indication of, how flat my pavement is. Some of the stuff says check every 25 feet for this. When you get into larger placements, this frequency is probably extended out beyond the 25 feet, and take a fraction thereof what the placement is. And then document the deviations. A lot of people will use a grease marker or paint, to document what's going on. And from the inspection world, this is a big thing, is to, ensure that the concrete is being, manufactured in the way that the documents say it should be. Strike off and screeding. If we have any handwork out there in inspection, we want to make sure that they're screeding it to the form lines that are out there. We can go ahead and, correct the elevation if it's not. We use a straight edge to check that, very similar to what you were seeing in the previous picture. We should check this periodically throughout the project, looking at it and then also putting it on a flat surface and looking for that quarter to eighth inch deviation um, on these. And then also maintain continuous forward motion. You don't want to see them going back and, cutting off bumps or ridges in there. You want to see a good movement across the concrete placement, always moving in a forward placement towards the end of that concrete placement. Consolidation, this is a little bit different than what we saw in the concrete pavers. This is a hand operated vibrator. And what we're doing is consolidating that concrete. And this is a bridge deck application. We're getting it to work through that reinforcing steel. And we want to make sure as we have the proper head size on the vibrator to ensure that it's not hitting the steel. If it is hitting the steel, they make protectors for that. But we really want to make sure that we have the proper radius of action, so that includes what is the VPMs and then also what is the head of the vibrator to ensure we're getting proper consolidation and what the frequency should be for the insertions of the vibrator into the concrete, so we don't get any honeycombing, whether we don't, so we don't get excessive vibration and, push and get segregation of the aggregates out. We want to eliminate the entrapped air. We don't want to eliminate the entrapped air. So the entrained air. Entrapped air are the large air bubbles that come out more readily through vibration. The entrained air bubbles are the bubbles we put in there purposely to go ahead and help the concrete survive from freeze-thaw durability. And then we ensure around the dowels and forms. So you will see on some projects, if they're not getting all the proper consolidation, you may see a person on the project giving that area extra attention with a specific vibrator. So after we placed all the concrete, we want to talk about the initial finish. This is going to be a little bit different. We're going to have two things. You can finish concrete in a hand application, when you're hand placing it, and or paver, and we'll go over both of those. But a lot of times what you'll see is a bowl float. And in that picture, you see a gentleman bowl floating across it. And the purpose of a bowl float is to close that surface up or to consolidate that surface to a smooth finish. There are other methods out there, and a lot of times what you'll see on a concrete project for a paver is a bump cutter or a highway straight edge that they use at different angles and multiple passes to create that smooth pavement. So go ahead and make sure that they're using the proper equipment for the proper application. You might see a little bit of hand finishing on the edges to get that to close. A lot of times you will not see this in a paver application, but more in your hand set, form application. And the biggest thing is we got to, make sure we're not overworking the surface. And you want to go ahead and make sure that they are using their finishing techniques to close the surface enough to give it the proper finished texture. We don't want to see people out there scrubbing on hand boards We don't want to see people out there, on the slab manipulating that surface because we're going to go ahead and cut that durability down. So on the inspection side, we want to ensure that they're using as much effort as they need to get the proper surface, but not so much effort that they are manipulating the concrete to, you know, cut down the surface durability. Just a couple examples of, what hand finishing would look like. The one on the right-hand side, absolutely not on exterior concrete, but this would be a machine finish. Any machine finishes are going to be used on interior applications. So from the inspection side, if you do see a motorized machine uh, finishing your concrete, that is a um, severe no that's out there. So with that, the right hand side picture would be for interior applications, and the left hand picture would be for exterior, hand finishing out there. Machine finishes can help with the consistency and the texture, and then with both of these, operator skills are critical. So if we're using a concrete pavement, the three main ones out there is a drag, a turf, or a burlap. And in this picture, you can see they're doing a burlap drag. On the inspection side, a big thing to ensure is that that burlap is wet enough that it's not taking moisture away from the concrete, but it is not so wet that it is diluting the concrete paste on top. You might see a broom where you have an individual come back and pull the concrete, pull a broom across the concrete. Sometimes you'll also see kind of a rack system that'll go across. You'll have one person pulling it from one side to the other. The reason for this is to give us an anti-skid and also help with drainage. Big one here is prevention of rapid evaporation. So as an inspector on the job, you know, you could look up. There are many tools out there to tell you when you're getting in the danger zone for rapid evaporation of the concrete. This is when water is not being replaced at the surface quick enough from below in the concrete, and the top surface is drying out, which is our durable surface that we need, for our concrete pavements. So you can talk about windbreaks, you can talk about fogging, you can talk about shading. There are evaporation retarders out there, and there are also finishing aids out there to help out with. Cold weather, we talked about this a little bit earlier, but thermal blankets are one of the main methods that are out there. And then we also want to make sure that we're maintaining uniform conditions, and that goes back to the weather. Is if Monday's 50, Tuesday's 70, Wednesday's 40, and Friday is 80, we want to try to maintain the best we can that the concrete gets cured for all those conditions and all those weather incidences.
We do have,
Question?
yeah, we got two questions. One is rapid evaporation causing the majority of surface cracking?
So rapid evaporation will lead to surface cracking, and what it is that there's not enough water. It's leaving that top surface more quickly than it can be replenished. So if we look at, there's plenty of tools out there that suppliers have, producers have, to tell you when you're in a rapid evaporation situation. And what that has to deal with is your wind speed, your temperature, and your relative humidity. Those are the best things to give you that indication. Multiple applications on your phone that will grab it immediately. Pretty cool tools out there to say, yes, we're in a situation. We have that. We have to prevent. We have to get the whether it is a fogging or an evaporation retarder or a surface finishing aid, to employ those.
The next question is when do you use anodes on rebar?
I can't answer that question, but I can forward it on.
Sure.
I have seen them used, usually on a bridge deck application when there is remediation. If you're doing a silica fume modified concrete out there, when they are just hydro demolishing, they'll use an anode in the concrete, but to give the specifics of when and when not to use, again, that would go to a design engineer.
Sure. And then the last question we've got is, can you clarify why it should not be allowed to use a troweled machine for exterior exposed surfaces? What impacts does the trowel have on the surface finish?
So anytime you use a mechanical trowel, a power trowel on the concrete. What you're doing is you're densifying the surface. And in densifying the surface, what happens is you're actually, pushing the water out of that cement paste. And in doing that, not only do we dehydrate that cement paste with that over manipulation of a machine, we're going to go ahead and work the air out of the concrete, which we intentionally want to put in there for the freeze thaw durability. And the third thing that really happens too is if you put that machine on the concrete, you're going to go ahead and seal that surface. And if we seal that surface, the bleed water that's still in the concrete is going to come up underneath there and it's going to sit. And once it's sealed in the concrete in an exterior application, um, as soon as that water dissipates through evaporation, that surface is going to sheet right off. It's very, if you've seen it, it's very indicative of knowing what's going on. That whole area will come off, and then you'll have, because that top surface isn't durable. But the big thing is you're going to, create delamination, but you're also going to work that air out of that top surface, that's what we need to preserve. So that's why machine finish on exterior concrete is a very bad thing.
All right, perfect. Last question here. Are curing compounds used for preventing rapid evaporation?
No, curing
Okay,
compounds are used after your finish has been applied. So after you've textured the concrete, this is the period before you would cure the concrete. So this is from placement to getting us to curing. That's when rapid evaporation really hits us hard. It can hit in the curing period, and curing compounds will help that. But we're talking about that period of striking off, finishing, and before we get to curing that we're seeing that rapid evaporation. That's where these other products have to be employed to make ensure we're not sacrificing that surface.
perfect. All right, that gets us caught up. For folks, if you do have to jump off early, I did just put the survey link into the chat. So we'll continue on, but if you did have to jump off early, that is already in there so you can get your certificate of attendance for today. All right, let's keep going.
Excellent. So please don't jump off till you get through the next 3 slides. They're very important. Paramount, curing, always and every time. As an inspector, you want to make sure that curing compound is getting put on the concrete. ASTM C309. Average square footage is 200 square feet or 25 square yards per gallon. Curing, 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 curing. We need to make sure we're curing this concrete immediately after final finish. So as soon as your concrete professional is done manipulating the concrete, getting it in place, getting the surface texture on that they need and want, cure it, cure it, cure it. Maximum time to wait is 30 minutes. Most contract documents for pavement applications have a 30-minute time window, but as soon as possible under that 30 minutes. It helps, prevent early evaporation, from that surface drying out, but it won't take all the plastic shrinkage cracking out of it. And again, curing, always and every time. We have liquid membrane forming compounds, white, paint it like a piece of paper. Make sure it looks like a piece of paper coming off of your copier. And again, as soon as possible, 30 minutes and under. Immediately is best, but put that curing compound on as heavy as you can. We can also use wet burlap blankets. Ensure that these blankets have been soaked before application. We do not want burlap taking water away from the concrete. It's critical that this burlap stays wet the entire time it's in contact with that surface. And then we can use plastic sheeting. Plastic sheeting is great. It does put that moisture, keeps it right into the surface. The downside of plastic sheeting is you will get modeling of that plastic sheeting on the concrete surface that does not go away. How long do we cure for? Minimum 7 days or per specification. This is up in the air, but from ACI, ASTM, all the documents out there, PCA, ACPA, 7 days. 7-day wet cure is general practices in the industry. Helps with early strength achievement. You can also use maturity meters to tell you, what the time frame is for those things. And then document. Key items document is going to be weather, the mix time, test data result, equipment use, observations, and corrective actions that are out there. So we want to make sure that we're documenting everything that we can as inspectors. So when we come back, we've got things to look at and things to compare it to. Surface tolerances, we've touched on this one a couple times. This is how we, can check the surface flatness, the cross slope checks, looking for that straight edge tolerance, like I said, 1/8 of an inch to 1/4 of an inch over a 10-foot span. We can also measure the smoothness by using this, checking these surface tolerances. Question?
Yep. Do you have any experience with people putting curing compound additives directly mixed into the concrete, or is that only ever applied to the surface?
So there are some chemical manufacturers out there that have some chemicals out there that they promote to put in the concrete as a curing compound. Um, right now, ASTM, ACI, the governing bodies that are out there don't recognize it as a curing compound. Because there isn't a way to quantify it. So as the association, and we're going to say put a standard curing compound on there till further data is available to prove that those are what they are. Um, so yeah, we would say use a standard 309 post applied sealer, and then follow that up with if you want to put a true sealer on ASTMC 1315 or a silene or siloxane sealer.
All right.
We're going to touch on a couple of joints. You're going to have your contraction joints. This is going to control the cracking. You're going to have your construction joints, which is, in between placements or start of production, end of production. And then isolation. Sometimes you'll see isolation joints around the structures or between slabs, that we're trying to protect so the concrete can move freely around that without just shearing off and cracking. Joint layout, we want to match the plans and specifications. Most of your jobs will come with plans and specifications that give you what your max spacing is in your joint layout. This is kind of a nice picture here to show how a contractor went ahead and came up with a unique design to make sure that they could dogleg the joint into that structure instead of just drawing it right across to go ahead and make sure that they're controlling the cracking. And then also, like, another one that comes about a lot is roundabouts, aligning your, joint plan with the traffic direction. When do we cut? 6 to 12 hours after finishing. This would be for concrete pavements, especially, this would be your final set that the concrete has had it. It can be a little bit shorter if you're using a soft cut saw to get on that. And the soft cut saw is meant to, give you your initial cut, not as deep and as wide to go ahead and prevent that cracking, early age cracking, and then coming back and widening that cut out with a standard cutting saw that's out there. So why do we joint? We're telling the concrete where to crack. And it delays the risks of the random cracking mid panel or, transverse in places that we don't want it. Joint depths need to be 1/4 of the thickness of the slab. Joint issues, what are some of the things we can run into? If we're cutting too early, we can run into some raveling. We talked about the misalignment earlier. We want to make sure that we're aligning those joints with the dowel baskets so that we get the proper reinforcement and the proper transfer from slab to slab. The other one we see a lot is insufficient depth. You should also, general rule of thumb for inspection, if you have any kind of feeler gauge or something that can go down in that into that joint, measuring that, making sure that they're cutting the proper depth. The left hand side picture, you can see some raveling, and on the right hand side picture you can see a random joint where the concrete just decided to go ahead and crack. Daily reports and logs, very important as inspection. Include photos. Talk about your chain of custody for the samples, and then digital or paper form inspection reports. Depending on what kind of work you're doing. I know there's a lot of consulting firms out there that have gone the digital route. It's awesome. I understand the paper route too, because then you have a physical copy of what the inspector on the job did do. So photos are wonderful because it gives you a better, you know, idea of what's going on. And then, like I said, chain of custody, if it is like a DOT job, do we have QA cylinders or do we have QC cylinders? And, who, what, when, where, and how, where these go, and then the paperwork to follow. Communication. Communication is key on any project and an inspection. If you know who to communicate with, when to communicate with, and how to communicate with, it's going to give you a better project. So inspector, contractor, coordinator, if we do have an issue, who do we talk to? Process of the resolution, and then pre-pour and daily briefings. These are great. If we can get everybody on the same page, where our inspector knows what our contractor is doing and our concrete production facility, how many yards they're planning on doing, yards per hour. Just that 10-minute meeting as an inspector, if you can get in on those, can make your day go much, much better. Some of the common surface deficiencies we can see out there, scaling being one of the biggest ones right now that a lot of people are talking about. Cracking, plastic shrinkage cracking, you'll see that's when the water's leaving the surface too quickly, and that's a picture on the left-hand side where you see those cracks running perpendicular, usually to the wind direction that day. And on the right-hand side, you'll see some honeycombing where you see where the paste has moved out of the concrete and we just have stone and rock around it. We don't see a ton of thermal cracking. It can happen. Most of the time, that's going to be done in large placements if we're doing huge abutments, and not mitigating the temperature of the concrete with supplementary cementitious and or other curing methods. Or, sorry, not curing, cooling methods. Just a picture of joint consolidation issues. This is just showing if they don't get that concrete consolidated around um, that dowel bar, this is something we might see, where they didn't have their vibrators properly. If there was a joint or a dowel bar inserter and it didn't get inserted properly, and or around the dowel basket, if they didn't have somebody go out and ensure that they were getting the proper consolidation around these. So, and then we're going to talk about some curing deficiencies. A lot of times what we'll see is incomplete or delayed curing. The incomplete is not following manufacturer recommendations of approximately, 1 gallon of curing compound per 200 square feet or approximately 25 square yards. Delayed curing, we want to make sure we ensure as soon as possible or within 30 minutes. Uneven moisture retention, going back to that burlap, making sure it's wet and moist across the entire thing and kept moist. And then surface discoloration, and then you can see that from your plastics a lot. And that's a picture of surface discoloration from using plastic curing compound. As you can see, that modeling, where every wrinkle was in the concrete surface in contact with the plastic. And then getting to the key points, inspection throughout each phase, from the design, investigation, design, to putting in your base, your sub base, and then going ahead to your concrete pavements and inspecting your concrete pavements to ride quality. Inspect throughout each phase and know what each phase has and what the requirements are. Document, 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 and then communicate if you see deficiencies and make sure you're communicating to the proper parties. And then know the specifications and standards. So when you're stepping on the job as an inspector, know what we're inspecting, when we're inspecting, and how we're inspecting. And that is what I have for you. Is there any other questions?
Doesn't look like there's any questions in the chat. Let me put the survey link in the chat one last time here. If you do have questions, feel free to ask them. You can also, Mark's got his contact info up there. You're free to send messages directly to him. Thank you all for joining us today. I also did put into the chat, I have another class tomorrow that is about hot weather work. If you're interested in that, we're going to repeat it on June 17th in a couple of weeks. So if you can't make it tomorrow, maybe check out the one in June. Thank you again, Mark, so much. The survey link, let me put that in the chat for you if you guys need it. Please use that evaluation. There's a question that says, what other topics would you like to see? Please let us know what other topics. We're happy to have Mark and Steve and Heather and anybody else at Michigan Concrete Association come back and talk about some other topics that might be helpful for you guys. So please let us know what else we can do for you. That is our job. That is what we are here to do. Oh, and yes, I can put the slides in again. I did that at the very beginning, but I did not do it again. So there's the slides if anybody wants to grab those. I'm going to stop the recording now.